forms of radicals. So the rules for rational exponents are, if m and n are positive integers, then a to the m over n power is equal to a to the 1 over n to the m power. So example for that would be like a to the, excuse me, my iPad flipped around. A to the 2/3 power, for example, is equivalent to a to the 1/3 power times 2 is a way that we can rewrite something. And then the next rule that helps us is if m and n are positive integers, then a to the m over n power is equal to the nth root of a to the m power. So for the same example, if we have a to the 2/3 power, we can rewrite it as a underneath a radical, and then put the 2 or whatever your numerator is on the inside of the radical, and put the denominator, which is 3 in this case, on the outside. So those are the basic rules for writing rational exponents as radicals, because we can go back and forth between these two forms depending on what we need. So let's look at a couple of examples. So example 1, we have 8 to the 2/3 power. So I'm going to rewrite that. Let me get a smaller pen. And I'll use this. Let's use a different color. Okay, so 8 to the 2/3 power is equal to 8 to the 1/3 power squared. That was our first rule. And the reason it might be easy to write it that way is because then we can use that second rule to say that the 1/3 power is equal to the cube root of 8 to the 1st power, and then this is still squared. Because the cube root of 8 comes from 2 times 2 times 2. So the cube root of 8 is 2, and then we can just square it to finish simplifying. So we get 2 squared, which is equal to 4. And we can certainly type this in our calculator, but that's how we would do it by hand. Let's look at example 2. We have 27 to the negative 4/3 power. So first let's rewrite it as 27 to the 1/3 power, and then scoot that negative 4 to the outside. And that helps because the cube root of 27 comes out evenly. So let's rewrite the 1/3 power and the cube root mean the same thing. So then the cube root of 27 is 3, because 27 comes from 3 times 3 times 3. And then we just have to take that to the negative 4th power. So remember with exponent rules, a negative can be fixed if we move what we have to the denominator. So we put 1 over 3 to the 4th power, and then that is just 1 over 81 when we multiply 3 times 3 times 3 times 3. We get that 81 on the bottom. Alright, let's take a look at example 3. In this case, we have two like bases. X is the same for both. So we just have to use our exponent rules to put these two together. So x to the 2/3 times x to the 4/3. Since they have the same base, we're allowed to add the 2/3 and the 4/3 together. And then they have a common denominator already, so we can just put that together as 6/3. And then that's just equal to x squared. So that is it for example 3. Now example 4, you have x to the 4th, y to the 1/2. Those are not like bases, so you have to keep them separate. But what we can do is distribute the 1/4 power by multiplying it by each one of those. So I'm just going to write that out. And then we just have to clean those up. So 4 times 1/4 would just be 1. And then 1/2 times 1/4, you multiply across the top and across the bottom, so that would be 1/8. And then we're able to just clean that up a little bit more because we just don't normally write the 1 with the x. So we'd say x and then y to the 1/8 power. And then keep in mind that's equivalent to x and then the 8th root of y. Those are equal statements, neither one is more correct than the other. It just depends on what you would need when you're working on a problem. Alright, let's look at example 5. Let me grab one more color. This one has 3 different variables, but 2 are the same, so we'll deal with that in a minute. Let's first just distribute this power of 3 to all 3 parts. So we have a to the 5/3 times 3, b to the 2/3 times 3. Let me write that a little better, because it's not up higher than the a. So a to the 2/3 times 3 at the same level. Then on the bottom we have a to the 2 times 3. So once we clean this up, it's like 3 over 1 is really what we're multiplying by. So again, multiply across the top and the bottom. So it would be 15 over 3. And 15 divided by 3 would just be 5. And then we have 6 over 3. So 6 divided by 3 would give us a 2 on the b. And then on the bottom we have a to the 2 times 3, which is 6. So then there's just one more thing we could do, which is to combine the 2 a's, because they are like bases. And when they are like bases, we can combine them. So think about 5 a's in your numerator, and then you have 6 in the denominator. So what happens is all 5 in the numerator will cancel out with 5 in your denominator, and you have 1 left. Or you could subtract 6 minus 5 and you're left with 1a in the bottom. And so it simplifies to just be b squared over a. So that one took a couple of steps. But there are all the examples now for things that we might see with equivalent forms of radicals. Because rational exponents and radicals go hand in hand. It just depends on what form